What is up, team? Today we're talking using trigonometric ratios. See the learning target here. I can use the sine, cosine, and tangent ratios to find the missing side lengths in right triangles. So a quick reminder, SOHCAHTOA. We're going to be using SOHCAHTOA a bunch of times. If this doesn't mean anything to you, please watch the previous video. Because if you're not on board with SOHCAHTOA, the rest of this video is going to be meaningless. So go back, check that out, make sure you understand SOHCAHTOA. Let's move forward now. Say we have this triangle ABC. It's a right triangle. We have a B is 41 degrees, C is 49 degrees, hypotenuse is length 100, and our question is this: what is the length of side AC? So we have a task of finding this length right here. Let's give it a name. I'm going to call it X. And we are going to use trig ratios in order to figure this out: sine, cosine, and tangent. This one happens to have two different totally correct ways to do it. So we're going to look at it first from the perspective of angle B, and then we're going to look at it from the perspective of angle C, and we're going to see what we can see, check out a few different ways to do this. Have your calculators handy. Let's dive in. So the first way I would encourage you to look at this, we'll start from angle B, and we're going to look at the three side lengths that we have. Well, really, we just have one, and we're wanting another one, and then we have this one over here that, we don't know what it is. And the question doesn't even ask for it, so we don't even care what it is. So we're just going to ignore side AB for now. We're going to focus all of our attention on sides AC and on BC. BC we happen to know, AC is our task. So let's think of our trig ratios that we remember: sine, cosine, and tangent. Which of them involves the opposite side and the hypotenuse? So opposite side and hypotenuse, if we look at SOHCAHTOA, sine is our opposite and hypotenuse, so we're going to use the sine ratio here. So the sine of angle B, the sine ratio of angle B is the opposite over the hypotenuse. So let's capture that. Sine of, angle B, but we actually know what the angle measure is. In this case, it's 41 degrees, so I'm just going to plug that in right away. So I'm going to say the sine of 41 degrees equals, again, opposite over hypotenuse. So in this case, it's X over 100. Here we go. Now we're going to use a little bit of algebra. We set up an equation using SOHCAHTOA, and now we're just going to carefully solve using our Algebra 1 skills plus a calculator, because, of course, sine of 41, I don't know what that is. I need to press the buttons and have the calculator let me know. So the first thing we're going to do is multiply both sides by 100 to get rid of this fraction. So if I multiply this by 100, I'm just left with X. But on the left-hand side, the 100 just becomes basically my coefficient, sine of 41. Remember, sine of 41 is just some number. This is a ratio. So when we plug in our calculator, we're going to end up more than likely with some decimal. Then we'll multiply that by 100. And on the right-hand side, we just have X. We've already have that isolated. Okay, so in my calculator, I'm just going to type this out. 100 times the sine of 41, 100 times sine 41, close my parenthesis. And when I click equals, I get this cool number. 65.6. So X equals 65.6, and I'll go one more digit, 61. So this tells me if X equals 65.61, we're called this X. Our claim here is that length AC is 65.61, and that seems reasonable looking at what we have here. If the hypotenuse is the largest leg and it's 100, that means the largest side, and it's 100, that means both these legs have to be less than 100. It seems reasonable that this would be 61. There's a way to confirm, however. Let's look at the same exact problem from the perspective of angle C. So we're going to put this on hold. We're going to hope that we match it here. So this is method number 2, not even a different method, perspective number 2, let's say. From the viewpoint of angle C, we're looking at the same sides. We're still looking at leg AC, still looking at the hypotenuse, but from this perspective, we're now talking about the adjacent leg and the hypotenuse. So looking at SOHCAHTOA, there's a different ratio that deals with the adjacent leg and the hypotenuse. It's cosine. So we're going to set this thing up. Now it's cosine of angle C, which is 49 degrees. So cosine of 49 equals adjacent over hypotenuse, X over 100. Okay, notice how these are pretty similar, at least on the right-hand side, X over 100, X over 100. So that implies, we're just going to take a step back here, that implies that sine 41 has the same value as cosine of 49. That's pretty crazy. We'll come back to that. Okay, multiply both sides by 100. 100 times cosine of 49 equals x. Again, calculator, typing in 100 times the cosine of 49, close my parenthesis, and I got the same thing. Excellent, 65.61. So that side is indeed 65.61 units in length. And of course, if we wanted to find that other leg over here, we could do that. We could do some Pythagorean theorem. Also, if we have this, we could do the same type of method using tangent. Say we could do the tangent of 49 equals opposite, which is we'd call y, or whatever variable we want, over what is now 65.61. So we could totally solve this triangle with using the tangent function. Okay, something I want to spend just a moment on. Notice that the cosine of 49 and the sine of 41 have the exact same ratio. So that's a relationship that's always going to occur with these triangles. So the acute angles within a right triangle are always going to be complementary to one another. We know that because the three angles have to add up to 90, but 90 of them are already taken with the right angle. That means these two have to add up to 90, therefore by definition they're complementary. So if you have two complementary angles, the sine of one angle is going to be equal to the cosine of the other. And then if you have the sine of the second angle, let's say, it's going to equal the sine of the first. So that relationship's always going to be true, hence two perspectives, two different ways to solve the exact same problem. Okay, let's do one more example. Okay, our second and final example, we have triangle, right triangle, RHS. R has a measure of 62 degrees, angle S is 28 degrees. Our task is we're going to find the length of RS. That's our hypotenuse. I'm going to name it Y just to mix it up a little bit. We're going to use trig ratios yet again. I'm going to make a choice here. I could choose to come at it from the perspective of angle R or from angle S. I'm going to choose S. It's arbitrary. You could choose the other one. You'll get the same answer just like I showed in the previous problem. So I'm going to look at it from right here. So S, I have the adjacent side, which is 18, and I have the hypotenuse. So if I have the adjacent and the hypotenuse, I'm looking at SOHCAHTOA, adjacent and hypotenuse, that's cosine. So I'm going to look at cosine of angle S, which is 28 degrees. And the ratio of cosine is the adjacent leg over the hypotenuse. So the adjacent leg is 18. The hypotenuse is x. Similar but different than the last one. This is just going to be one extra step. It's annoying. We're going to toss the variable around a little bit. So here we have to multiply both sides by x. We can do that because x is just some number. So now I have x times the cosine of 28 equals 18. The fraction is now gone, but now I'm multiplying this ratio by a variable. That's annoying. So I'm going to divide both sides by cosine of 28. Cosine of 28, I know it's three letters, two numbers, but really it's just one number. So if I divide this whole side by the cosine of 28, x is what remains. And on the right-hand side, I have 18 over the cosine of 28. Of course, you could have thrown the cosine of 28 into your calculator, had some decimal that you're working with, and had that follow through all the way here. That works just fine. I chose to leave it as cosine 28 for now. Okay, now we just need to plug this expression here into our calculator. 18 divided by the cosine of 28. I don't know what that is, so I'm going to get my calculator. I'm typing in 18 divided by, and then I'm typing in the cosine of 28 degrees. I'm closing my parenthesis. I'm pressing equals, and this tells me that x equals 20.39, rounding to the nearest hundredth. Looking at my figure here, if I have a leg of 18, I know the hypotenuse needs to be longer. This is indeed longer, so this seems to check out. Okay, so we found the length of our hypotenuse. Let's take it one step further, though. I want to find the other side without using Pythagorean theorem. So this is 20.39 units. I now want to find this third side. Here's how we're going to do this. So this is for side RH. Let's keep looking at from the perspective of how do I want to do this? Yeah, I'm going to keep it from the perspective of angle S here. So this time we're looking at the opposite side and an adjacent side here. So opposite and adjacent, that's tangent, TOA here. So we're going to do tan of 28 degrees equals the opposite side, which in this case we're calling Z, over the adjacent side, which is 18. So this is the first time we're using tangent, but we're solving it the same exact way. We're just doing a little algebra and number crunching in the calculators. Multiply both sides by 18. Tan 28, boom, boom, equals z. Calculator time, 18 times tangent of 28. Close my parenthesis, and we learn that z equals 9.57. So this length up here is now 9.57. Less than the hypotenuse, so it makes sense. Clearly, I didn't draw this according to scale, but it seems to make sense. This angle measure is 28 degrees, this one's 62, so this one's open much wider, this should be narrower, this side's going to be shorter. Checks out. So we were given a right triangle. We were given all of the angle measures. We were given one of the side lengths. We used our trig ratios to find the other two side lengths. Didn't even touch Pythagorean theorem. Pretty cool. Feel free to pause, rewind, do what you need to do. Ask me questions if you got them. Practice problems in our classroom. You got this.